All right, so let's say dy dt equals 2x. Okay, 15, 14, something like that. All right, so what is the general equation for this? And what would the graph of this look like? Well, I'm wondering, what's the graph of this look like? What does the graph of this function look like?
Let me look at my decimal quick. So is it a
As Truman said, it's a parabola. Okay? It's a parabola. Why? dy equals 2, no, that should be an x, I guess. 2x dx. Okay, we integrate. So y equals x squared plus c. So it's a parabola. It could be down here, it could be here. What determines where it is?
C.
The c does. Exactly. The c does. What's that graph going to look like? This is linear. Okay? Because this would be something with a slope of 5 because dy equals 5 dx, integrate y equals 5x plus c. And where it's at is all dependent. All right. So you guys can get that. I'm not too worried about that. Okay?
Is this the? Oh, it's directly proportional. Is this the P-E-K-T?
No.
C-E-K-T. Is this like the T-Y-D-X equals K-A or whatever? Yes, Truman, it is.
All right. The rate of change in volume is directly proportional to the square root of the time that is changing. How do we write that? As a dv dt equals k square root of t. Okay? The rate of change of volume, because the volume is changing with respect to time. Okay? Because if something is changing, it's generally changing with respect to time. So you need the dt on it. So if this one happens to be directly proportional to the square root of the time that it's changing. So let's say volume is changing over time, which is indirectly proportional to the time, the square of the time. So dv dt equals k over t squared. Okay? So we got the proportion stuff down, right? Okay, that's generally good there. Now, oh, AP is a little different than Khan Academy on some of this stuff, and here is something I need to cover with you not listening. I think you want to listen to this. You need to listen to this. So let's figure this out. Dang it. Differential equations. Where'd you go in this book? Right?
Me too. That's better.
There we go. All right. So,
I don't know how to explain it. Like, you can't explain it.
It was a satisfying food, but I don't think we're losing it. I don't think you have enough water.
No, I'm very confused. It was like almost like one of those like suction cup, and it like unhooks.
Because I think you need more water so that you have more water over, and then it makes a bigger food.
Gotta calculate the volume.
Do you, Dylan, did you need that?
Yes.
Yeah, and so we thought that was satisfying. We wanted to hear it again. You too?
Not even 2 water.
Hydration. Oh, I hate you. Oh, so you take a while.
Ellen,
We did take an Ellen, and then
Ellen would probably do that.
where's the Ellen though? Where's the Ellen? I think what you ought to do is just like make the needed review questions exact same as the test.
What do you mean, where did you?
Ties onto something.
It can go anywhere.
I would think the lie out.
all right. So,
They plug it in.
is y equals x squared the solution? So what do? Well, let's take the first derivative of this. So the first derivative is 2x. Then we stick the first derivative in for that. So x times 2x minus 2 times, what's y? X squared equals x squared e to the x. So we replaced y with what y is equal to and y prime with what y prime is equal to.
X to the third, Truman.
X to the third right here. Can't you read, Truman? All right. So 2x squared minus 2x squared equals x cubed e to the x. So then, is 0 equal to x cubed e to the x? No, that doesn't work. Okay, now let's do another one. Does this work? Same equation. So xy prime equal xy prime minus 2y. Excuse me. Come on, pen. Minus 2y equals x cubed e to the x. Is y equals x squared times 2 plus e to the x a solution for this? Is this a solution to this? Well, how do we tell? Plug, chug, solve. Y prime equals, take the first derivative of this, which is x squared times the first derivative of the second part.
2x plus.
No, just e to the x plus the second part, 2 plus e to the x times the first derivative of the first part, 2x. Remember product rule? Yeah, you have to use the product rule. These are multiplied times each other. So we plug that in. So x times x squared e to the x plus 4x plus 2x e to the x. Oop, 2x e to the x. Minus 2 times y. Well, what's y? Well, that's 2x squared plus x squared e to the x equals x cubed e to the x. All right. Got all that? Let's see if those are equal. So if we distribute the x through here, we get x cubed e to the x. Really? My stylus just died.
Yeah, Ty, really? Really?
You need some dry stuff? What?
Hi. Did you check in with Charlotte?
I have not wanted with him.
Well, you need to check in with Charlotte. But
I wasn't here. I've been texting all morning. Are you looking at, like the Y prime?
all right, here we go. So x cubed.
Cause I didn't understand that either, but I chose not to say it.
What is the problem?
Well, when you took the first derivative of Y, I just, maybe I don't know. It just didn't seem right.
The first derivative, the first times the first derivative of the second
Why did you keep the X squared?
times the second times the first derivative of the first. Product rule.
Oh. Oh.
So
I was thinking chain rule for some reason. My bad.
well, the 4x squared and the negative 4x squared cancel. The 2x squared e to the x and the negative 2x squared e to the x cancel. So we get e to the cube e to the x equals x cubed e to the x. Yes, it is a solution. Okay. Now, let's do one for the same problem with a sign involved. So, what's first derivative of sine of x? What's first derivative of sine of x? Regular cosine of x. Derivative, not integral. So, x times the cosine of x minus 2 times the sine of x. Is that equal to x cubed e to the x? Not even close. We're not even in the same ballpark there. Okay? So, well, that one was obvious. So you might have some that have like a second derivative. Let's take one with a fourth derivative. Fourth derivative. Why not?
So you're saying there will be a fourth derivative?
No, there'll only be a second derivative on the test. So you can see what goes on when we have a fourth derivative. Is y, let's say y is equal to the 3 cosine of x. Let's say y is equal to 3 cosine of x. Does this function work? So, the first derivative is negative 3 sine of x. The second derivative is negative 3 cosine of x. The third derivative is positive 3 sine of x. And the fourth derivative is 3. 3 cosine of x. And see how this loops back to this. But this says 3 cosine of x minus 16 times 3 cosine of x equals 0. Well, that one's definitely a no. Okay? That one doesn't work.
I told you it didn't work.
Let's say y equals e to the negative 2x. What's the first derivative? No.
Negative 2e to the
Negative 2e to the negative 2x. What's the second derivative?
negative or 4e to the
4e to the negative 2x. What's the third derivative?
Negative 8
What's the fourth derivative?
16e to the negative 2x.
So we get, if it's y to the fourth derivative minus 16y equals 0, 16e to the negative 2x minus 16e to the negative 2x equals 0. So this one is a yes. Can you do these now? Because the way he taught it in Khan Academy was horrible. And I didn't even understand he was doing this.
He did this?
Yes, but we didn't. He did it in such a god awful, horrible way. I didn't even know he was doing this. And once I figured out that he was doing this was on your test yesterday.
It was?
Yes.
He probably got it wrong.
Are we gonna have any crazy ones like the one you showed?
Like what I just did on the board?
The crazy one where you like contributed 19 times.
No. But what if we have this one? Let's do the second derivative minus 2 that equals 0. How about that one? Let's say y equals ce to the 2x.
So wouldn't it be 2c?
What's the first derivative?
2ce to 2x?
What's the second derivative?
4ce to 2x?
We're only doing it a second.
So 4ce to the 2x minus 2 times ce to the 2x. Does that equal 0? No.
Yeah, is this like our whole test or what?
No, it's just one question. I just because Sal taught it in such a god awful horrible way that I needed to reteach that in a proper manner so you could figure it out.
Can we write him a strongly worded letter?
No. But there are a couple problems with slope fields on there that you just got to figure out. Yeah, the struggle is real. You can struggle through them. It'll be fine. So, there are slope fields. What you can do is graph the function on your graphing calculator, see what it does, and see what's happening to the slopes and match it to the correct slope field. Did you guys try that yet?
I thought about it, but I never actually did.
You were
Truman, I've been sitting on you. Truman, I was, yeah, you just
I'm
doing it.
considering it. It'd be
Yeah,
useful.
just sit.
Okay, what's the general solution for this differential equation?
Quad 3y squared over dx of
Yeah, Truman.
I'm the slope field second in command.
All right, and then what?
Then you take the integral.
Because he's the slope field master. Sounds like last place.
Then what do we do?
Then you get y alone,
By
taking the cube root.
now on the test, be forewarned, on the test, it might be written like this.
Why do they?
That's the same thing as a cube root. 1/3 power is the same.
Isn't that worse?
That's how the Third Reich was. All I'm saying.
Okay.
You have to get a question from your credit.
Oh no! We might need our note card for this one.
I don't even know where my note card is.
Doesn't that turn into tangent though? I swear that turns into tangent.
But I,
It's not tangent.
You sure?
it is tangent, isn't it?
That turns into 1 over.
It's cotangent, you're close.
I got the T.
Right? That's off your note card. So make sure you know where your note card is for this test. Dude, you can figure it out.
Anything like this entire semester.
Literally means because it's a chapter. I haven't written any of the notes on the note card in this chapter.
Did he give us new formulas like last time?
I don't really need any of them. Like, the.
All right. So, what is the solution to this differential equation if y of 5/2 equals 1? What is the solution to this differential equation? Ty, you start us out. Ty, put your mask up.
Is today the 8th?
Today is the 8th. What would you do first, Ty?
Integrate.
No!
Shoot me. Take the DX over.
Move the dx over.
That's high.
No, you lied. Yes, you did. Then you integrate.
He did lie, so then he get made fun of.
I'm not in charge of this thing.
Yeah,
I'm
I,
gonna
you take it. Hey, you got this. What's the integration of negative cosine?
Tag out. Shoot. Jackson got. He tagged it out to me. -2 sine of x.
Nice.
plus-
Now what do you do?
And then we up yonder for the y we put 1, and for the x we put pi over 2. Then we whip out the old Texas instrument.
What's the sign at pi over 2 equal to? 1. So 1 equals -2 plus c, so c equals 3. So the general solution, the solution of this is y equals -2 sine of x plus 3.
Is that what they're gonna ask for? Like they're not gonna ask you to put in another number?
No, I don't think so. Just want the equation. Okay.
Can I go talk to Mr. Kirsten?
No. All right. So Mallory, first step in this.
You multiply the dx over and you multiply the y.
So y dy equals 2x dx.
Then you integrate. Oh, am I supposed to say the answer?
Yeah.
Oh, okay. 1/2 y squared equals x squared plus c.
Then what do we do, Dylan? No. No. All right, if you want to go there, I guess you can. But I don't want to go there. Let's not go there.
Just plug it in now.
Yeah, let's plug it in now.
Till you get find out c or what? Yeah.
So you get 1 is equal to 6.
I don't like it. Like, why can't you?
So y squared equals 2x squared minus 31. So y equals the square root of 2x squared minus 31.
Is it plus or minus or no?
It should be because that's what it was on someone's test yesterday, remember?
Yeah, and so then, since this occurs in quadrant 1, it should be positive. But if we're in, because this is the ordered pair 4, 1.
Oh, sorry, that's my bad.
But if we are in like quadrant 2 or quadrant 4, it would be negative. We're in quadrant 1 on this. But if, let's say on the test tomorrow, on
It's like -3, -3 or something.
Mr. Kirschbaum, I have a question, because I kind of forgot. It is.
what?
The quadrants like 1, 2, 3, 4.
Yep. All right. I'm just gonna tell you it's negative on the test. It's negative because we're gonna be in quadrant 4 on the
Why are
test.
we in quadrant 4? You said we're in quadrant 1.
On this problem, we're in quadrant 1.
Can you write down that we'll be on quadrant 4 in the test? On this note here?
No.
Oh, on the test.
Remember, we're in quadrant 4.
Wait,
We have a symbiotic relationship.
That leeches up.
That's basically it.
Yeah, we're all symbiotic except for 1/3.
You shame.
All right. So if dy dx equals y, and if y equals 2 and x equals 0, what does y equal? What is the equation going to equal?
You have the dx and dy over.
1 over y dy equals dx.
Oh my, this is a CD, isn't it?
Integrate. The ln of y equals x plus c. E both sides. So y equals e to the x, e to the c. So y equals c e to the x. So 2 equals c e to the 0. So what is c equal to? 2. So what is y equal to? 2 e to the x. Bada bing, bada boom. a kitten weighed 1 pound at birth and 4 pounds 6 months later. What did the puppy weigh, or what did the kitty weigh at 2 months? If things are proportional. So what do we know? Y equals CE to the KT. What is C? C is initial, right? So Y equals 1E to the KT. So then what else do we know? No, that's not 41 pounds. It's 4 pounds. 4 equals E to the K times 6. So 4 equals E to the 6K. How do we get K alone? ln. ln of 4 equals 6K divided by 6. K equals ln of 4 divided by 6. So we want to know the weight at 2 pounds. So Y equals E to the ln of 4 divided by 6 times 2 months. So Y equals E to the 2 over 4 is 1/3 ln of 4. Oh, that's nice. What is E to the 1/3 of?
Oh, so we're talking about house cats.
Okay, that is house
So if we take E to the
6 pounds.
See, that was reasonable for you.
1/3
1986.
ln of 4. It weighed 1.587 pounds.
They literally call it like sodas now.
All right, so 14 questions. I think and I taught you really well how to do the one that Sal just totally whiffed on, but besides that, I think this is fairly straightforward. I think you guys know more what's going on in this chapter than what you have in other tests.